As part of my KUKA robot project, I discovered a chap online on eBay in the US was selling a motor which is the same as one of the ones on my robot and would make an ideal spare part. What attracted me to it was the price. He had it listed for 55 US dollars. These things are going for $600 to $800 US dollars as a second-hand part, so I thought I'll take the gamble and purchase it. At least I could see what's inside of them. I didn't want to tear apart the ones that I had already. So I've got it, hooked it up. I wanted to check the resolver, make sure that works, and also the coils. So good news is everything's fine. What I did was went online to sort of know more about the resolvers. I didn't know how they work. Previous experience I've had with servo motors is they're using the optical kind. These ones don't. They use what's called a hollow tube resolver, and it is effectively a primary and secondary transformer setup that rotates around the shaft. So you've got an excitation coil, and then you've got excited coils, two coils that are 90 degrees opposed. And so to demonstrate what's going on, I'm feeding a 10 kilohertz sine wave, 5 volts peak to peak, into the excitation coil, and then the two coils that are being excited, as I rotate the shaft, you can see that they will be out of phase, they will be in phase, and they will also cancel out. So in phase, out of phase, cancel out. And that information is then interpreted by on the KUKA, I think it's called the RDC card, that transfers that into data and feeds it to the controller. Interesting what you can do with these if you change the time base. You can show the rotation. So testing the coil, I basically connected 3 wires to the YVW, I think they're called, connections, and just using a 12 volt battery to see that one's popped off. So here I'm just using red, green and yellow. So if we go green, yellow, and then we go yellow, red, and then we go red, green, we can see that all our coils are operational. That's great news. These motors have a brake which is engaged when it's not powered. So it's a 24 volt mechanism. To engage or disengage the brake, I just hooked up 24 volt power supply. So once you take the power off, that shaft is locked. To get the pin out on this, you can open up the back of the plug and check the color codes. It's a Tamagawa Seiki encoder or resolver, SmartSyn BRX. So I found a PDF online that gave me the color codes and which coils what, so I could connect to it and connect them to the scope and do a reading. Thanks for watching. Hope this helps somebody.